screen. I'll do that.
Okay, so I guess we are live now. We are live.
Okay.
Six. That's it. Okay, I think we should start now. Like, people, start. Okay. Okay then. Hello everyone and welcome. I am Devashish Verma from TFUG User Group Ghaziabad. I am also working in a domain of machine learning. And today we are starting the day forum ML Mass Club where we are with the speaker. So everyone just say hi and hello in the live chat box. So and mark their presence as well. Comments as well. Okay, so let's start now.
Okay. So, should I share my screen now?
No, let me introduce you.
So
So,
I'll introduce in 9 slides only, by the way, but you can start. Okay. Okay.
okay. So, okay, guys, hello once again. And let me introduce to the speaker of our today's session, Kritika Parmar. So, Kritika is a recognized expert in the field of machine learning with an excellent experience of neural language processing. She's had making made significant contribution to many tech talks and tech communities as well. And she was also an intern at Geek for Geeks as a data scientist intern, which was a very impressive. And now she's currently working as a machine learning engineer at FilterPixel. She will take a session on the mathematical insights into neural network architecture, which is a corner center of our artificial intelligence, by which Kritika will help us to gain a deeper appreciation for how neural network learn and perform. So, Kritika, the mic is towards you and the stage is all yours. Keep going.
Okay. Thank you, Dave, for a wonderful introduction. I'll just share my screen. Let me know if it's visible. Uh, Dave, is my screen visible? Everything fine?
Yes, everything is fine.
Okay, great. So I'll start. As already they have introduced me to all of you, I am Kritika Parmar, and today's the session is going to be on machine learning, majorly on machine learning, deep learning, and we'll take a like uh, like quite insights on the how mathematics works in something in ML and DL. Okay, so first of all, who am I? I'm a machine learning engineer at FilterPixel, and I have worked with other companies like Gig for Geeks, Accurate, and Particle also. I am a computer vision enthusiast. I love to do computer vision tasks related to images and all. Uh, I have given right now. I've given 5+ talks in GDG, GDSC, and GirlScript communities, and this is my first talk with TensorFlow user group. So I think it's going to be amazing. As I talk about my like personal, so then how my daily goes is like I fine tune models, machine learning, deep learning models, adjust weights, and apart from it, I play guitar and yeah. So if I talk about my day-to-day task at my company, then it includes preparing data, training or fine tuning, as I've already told you, deploying them and monitoring them. Okay. So now we'll go forward with today's agenda. So I have distributed it in two parts. The first part actually includes the introduction to machine learning, then to deep learning, then to CNNs, and then we'll have a short practical. And in the last of the session, we'll go through some latest trends. We'll have a short discussion, and then I will provide you some more resources if you like this field, if you want to dive more into this field. Okay, so let's dive. Okay, so before starting, let's talk about some traditional programming, how actually programming works. So, what if I want to write a program or any program to sum two numbers, right? So, what I'll do, I'll give the data. For example, I want the input data to be 2 and 3, right? And obviously, I want to add them. So what will be the algorithm or the you can say logic that will be a plus sign that will add two numbers. We'll provide that input and the algorithm to the machine, and then we'll get the output that will be 5, right? So this is how the traditional programming worked, where we have the input data, we have the logic with us, we inputted in them into the machine or the you can say computer we have, and then we got the output, right? So it was quite easy, but the thing machine learning started when one second when the when people started thinking about what if we just provide the data and the output to the machine, can it provide the logic behind it? So what if I provide the data as 2 and 3 and output also as 5 to the machine? Can it predict that it has been added, like the numbers has been added? So there comes the idea of the machine learning, where in which we try to predict the pattern or the hidden pattern you can say, or the algorithm that is that has led to the put of the input data. Okay, actually, I tend to go fast, so let me know in the comments if anyone feels any doubt at a time. Okay. So, basic of the machine learning is simple. We provide the input data with the output to the machine, to a black box, something like that. And then we expect the machine learning or the model or the black box uh, to to sorry for the background noise if there is, to actually get the algorithm or to find the hidden pattern of how we get from the input to output. Okay, so uh, simply, if just like I told you 2, 3, 5, then output will be like it was added. So when we like get into the more real data sites, then you can say this as ki, for example, I want to apply it on a very basic thing. I want to start predictions, right? So I can use this previously trained black box that I just showed here, that this black box machine that can just simply use this algorithm and predict the output, right? So this is how the machine learning start. Now I'm going to like give you some basics of linear regression and logistic regression. Before that, if we have any questions, I'm just looking at the chat section also. Hi to all, hi to all. Okay, so linear regression simply means when we are trying to fit a line, like simply we can say, for example, I have a graph here, right, which shows the independent variable x and the dependent variable y. And these are the points. Don't look at the line right now. These are the points that are already with us. Okay, so suppose we just have this x value, so and we want to predict what, like how will be the value for the any other new value. Okay, so what we do is we try to fit a line of regression according, like, on this data points. So these data points, uh, uh, we have these data points, and like if you can see that we have this line of regression. So what we do is we try to reduce the error. How do we reduce the error? Is we take the point, okay, and then there after this point, for example, just take this first point that we have with us. Can I use any marker or something? Okay, leave it. So we just try to fit the line, and then, for example, if we plot on these lines, the point on these lines, the distance between this, for example, this is the error. Distance between this should be minimal. Okay, and across all the points, across all the lines, the distance, or you can say the error of the predicted value with the like original value should be the minimum. This is how we try to predict the line of regression. In this, we basically simply use the formula of y equals to mx plus c, you can say, and then we try to train the model on this. So we call this a regression problem, because obviously we are dealing with you can say continuous values. We are not trying to predict like you can say a 0 or 1 or 2, something like that. Okay, so what if we want to just classify a problem in a 0 or a 1? Okay, what if I just want to predict that that the weight of a child, is this the weight of a child is this, that it is it comes in a obese category or not? What if it's just a 0, 1 problem? Then there comes the solution of the logistic regression, and in which you can see that we only have the points in the 1 and the 0 range. And what we try to do is we try to fit the S curve, which we call the sigmoid curve, and we try and whatever the values that we set a threshold value of 0.5, whatever the values are like greater than the 0.5, that will be predicted as 1, and whatever will be low, that will be predicted as 0. Okay, so this was somewhat about the linear regression, how linear regression helps in predictions, and like what is linear regression simply, what is logistic regression simply. Okay. Okay. Now we'll come to an interesting part where somewhat maths comes. Uh, while predicting the values, for example, we have a point x, and we have the like you can say the output value x and the input value uh, suppose y. So we take the difference of them, y minus x, and that's whole square. So suppose it comes to be a, okay, a square. So that's how the square of the like for a point is calculated. And when we accumulate all the sums, then we get the loss value. So there is a simple thing of which is known as gradient descent, in which we try to reduce the weight, reduce the loss by getting on some value of the weights. And our goal is to actually reach the minimal, you can say the minimal point where the like the curve, where the curve actually starts, like like starts getting towards zero, like you can say where the loss actually starts getting towards zero. Okay, so we have to reduce the loss like that. So what we do actually here is we take a learning rate, and learning rate is simply, you can say, a hyperparameter. Hyperparameter are simply the values that are actually contributing to the model learnings. For example, the weights, the bias, the learning rates, and all. So here I have taken two examples of the learning rate. If we are taking a small learning rate, and if we are taking a large learning rate. So if you are taking a large learning rate, then what will happen? It will just jump from the values, for example, right? It took from 0.8 to 0.8 jump, and then it will again come to 0.6, then minus 0.6. It will just keep jumping, and it will, the chances are it will never reach the minimum. And if we take the smaller learning rate, or you can say like generally it is taken around 0.01 or 0.001, then the actually the loss gradually decrease, and the like the predicted value of the value of the weight is, or the you can say the intercept is like uh, like very you can say gradually is decreased, not very not we cannot see the jumps there, the values are not directly increased to a certain number. Okay. Okay. So now I have a like question which actually is asked in some interviews. Why is logistic regression called logistic regression and not logistic classification? So if anyone have any idea, I am waiting for 2 minutes, but okay. So actually, in regression, we use the function uh, z equals to wx plus b, and then we actually apply a sigmoid function to the value, which so like logistic is similar to the regression. The first part is similar, where we are just simply calculating the z, you can say the z value, and then after we got the z value, then we are regression. Yeah. But logistic regression, it is called logistic regression because because the first part of the calculations is related, it's similar to the linear regression, and it's just the last part that we use the sigmoid function. That is only the part where we apply the sigmoid function, and then change the value to a probabilistic value where it can be ranging between 0 to 1. Okay. So I think it would help you if someone asks. Okay. I gave a basic of linear regression because that will be the starting point of, uh, you know, uh, the artificial neural network or neural network if you want to go into. So now we'll start with artificial neural networks. So we we actually try to mimic brains using we have the say we can say this is a biological neuron that you can see on the screen, and we actually try to mimic this. The dendrites, acts as the input, the soma acts as the processing point, and the our synapses acts as the output. Okay, so we actually tried to the scientists actually tried to mimic this. Like, what if we put input in the form of dendrites, then we just like you can see we are doing some here, and then we can add some activation function, and then we can expect the output. So this is just our neuron that you can see ki we are taking x1, x2, x3, and then we are applying some weights on it, and then we are adding w1 x1 multiplied w plus w2 x2 plus w3 x3 and plus the bias that we take, and then we actually get the sum, and then on that summed value we actually apply the activation function on it, and then we have the output for that particular neuron. And now this neuron's output will be inputted to another neuron. Okay, so this was the idea behind the starts of the artificial neural network. Okay. So after moving, before moving more forward into deep learning architectures, I wanted to talk about activation functions, which also come as a crucial part in interviews. Like interviews like to ask them. So I'm just having some basic activation functions here. The binary step function is simply when we are just predicting the value to be 0 or 1, where we just set a threshold and we predict the value. The sigmoid function that we have seen previously also in the logistic regression is simply when we predict predict the values to be between 0 and 1, that are the probabilistic values. The tanh is similar to it. But the range here changes to -1 to 1. Okay, next we have a very important activation function, the ReLU function, which actually changed the neural network back propagation method in a very, like, we actually achieved it in a very easier way, because sigmoid and tanh can be like very hectic to work with when we are going back in the neural network to again change the update the values to make the model learn to reduce the loss. Okay, so what ReLU does is simply, if the value of the, like, we took the neuron as inputs, then we did the sum, then we applied the activation function, and then we got the output, right? So when we got the output, the ReLU does what it does just behind step. If the value is less than 0, the negative value, it will be converted to a 0 value. Okay, so for example, we have a -5 that will be taken to the 0 value. So this output of the neuron will be 0. So what it did, it actually acted as a on-off button. Okay, so it will just keep the value as 0, or the value if it is greater than 0. Okay, so it actually just is keep, you can see now the neuron here is actually just an on or off button. Okay, so it actually contributed to a problem which we call as dead. I just I forgot that. So the leaky ReLU. Then we come to the leaky ReLU, which actually is like, we do not do the zeroth of the directly do the 0 of the ReLU, like we did in the 0. We for example, we have a value that is less than 0, then we do not actually directly do the 0 of the value. We take some, there is some negative curve that you can see. Then we have this ELU, which actually is a very, very good solution to the dying ReLU problem that we face. What happens actually in dying ReLU problem is some neurons are actually did. For example, we had 5 neurons, and out of them 3 neurons were 0. Okay, and then when we back propagate, and if we have too many zero neurons, too many like you can say deactivated neurons, then those neurons sometimes stay as deactivated only, and only some part of the whole neural network is used for training, and which becomes actually hard to train on a very big data set, or a very like image data set, or a very it becomes very hard. So we use actually ELU activation function. um in that, we, apart from it, like simple linear curve, we use exponential curve for the negative values. Okay, I think I can see some question. So if the first question I answer, how do different neural network architecture leverage mathematical concepts to handle various types of data? We'll just see that in a minute. What role optimization algorithms play in training neural network? How are they mathematically formulated? For the mathematical formulation, I have not added this into the slide, but yeah, I don't think like it is. I don't have added in this slide because the scope of this session was only 1 hour. So I'll try to answer that if there will be time left in the session. Okay. Otherwise, I don't want we are left with the session. Okay, so this was the activation functions that we will be using in deep learning architectures. So deep learning, before moving forward, why deep learning? So I already have seen a question here which says that like how to like take images, text, and audio. So we simply can see that so we simply can see that already we have the questions regarding to audio, texts, and images. So the problem was that machine learning, or you can say conventional machine learning algorithms, were not quite enough to solve this major data problem. For example, the images have a large number of pixels. We have very high quality images. We have text, and then we have audio. So we were not quite you can say ready for solving them. Then there came the artificial neural network that we saw, and then we got into the thing of deep learning, where we are using those neurons, and then we are just adding all those neurons in different layers, and then we are trying to predict an outcome. Okay, so why deep learning? Was simply because we wanted to try the prediction, you can say the prediction thing on very big, large data sets, or very on the problems of which included images, texts, and audios. Okay, so that's why we started with ha. Okay, so now moving forward to the convolution neural network. So I'm taking convolution neural networks here because I will be discussing on images. Okay. So I think I have a question here. Network issue. Hello, hello. Dave, is there any network issue with my side?
There's a bit of network issues coming from your side and audio as well.
Okay. What I can try is just to switch to the different network, but 1 second.
Just
Hello, hello. Am I audible now?
everything is fine.
Hello. Okay. Some people are saying that there is no issue now. Okay. So
Yeah,
I see one
it's fine.
question here. Vanishing gradient problem when training RNNs on long sequences. I think LSTM are used. And if I see in my day-to-day daily lives, if I face any vanishing gradient problem, then I try to, like play with some the layers, number of the layers of the number of the neurons I'm inputting in it. Um, how many layers I'm using, if it is like how many neurons I'm inputting in them. So I just try to play with them. You can try batch normalization. Right. So these are the some things that you can use for the vanishing gradient descent problem. Okay, so moving forward with the convolution neural networks. So in this, with these neural networks, we actually try to answer the image. If the input is the image, then we try to answer whatever like the output we want, zero or the ones or any threshold answer, or really like the regressive value or the classified values have shown in the screen from 0 to 9. Okay, so what we do here in convolution neural network is actually take image, apply some convolutions, then some pooling, then repeat it. Then we have a fully connected layer in which all the you can see the all the pixels in the 2D array is converted into a 1D array. Okay, and then we have you can add more layers, and then in the last you will have an output layer. Okay, so now we'll discuss more deeply how this convolution works or how this max pooling works. Okay, so convolution actually means to add a kernel um, in the image. So what I have done, I have taken some images from the internet, and this is a like 2D image, 2D input image, you can say, which have the size of 32 cross 32. That means 32 pixels cross 32 pixels, and it can be represented as this array, 2D array. You can see it is, you can see just inside of the image. Uh, then this array is actually multiplied to a kernel, which is also a 2D array of size 3 cross 3, and it is done repeatedly to like in like it is moved through the whole 2D array. Okay, so for example, first the kernel of size 3 cross 3 is multiplied with the first 3 cross 3 array of the image, input image. Okay, and then we get the output. So here it has done some calculations, and we multiply it to like 2D matrix multiplication we did here, and then we get the output. So in this way, we actually try to get some extra input. For example, if you want to take the just the edges, if you want to just know the edges of the images, then we take some kernel. If we just want to take the blur of the image, then we take the other input. If we like whatever information we want to take from the image, we apply kernel according to that, and then we get the output. It also decrease the size of the image, right? Because we have see the convoluted matrix. So in this way, we try to get some information that is present in the original image, and then this is applied to next layers also. Okay, so now we have pooling. Pooling is actually decreasing the like say the all the pixel values that we had, down sampling of images, you can say in other words. So for example, if I have a matrix of 4 cross 4, then I want to reduce it to the a matrix of 2 cross 2. So that will be done using pooling. There are different ways of pooling: max pooling, average pooling, and mean pooling. I have taken an example of max pooling with me. Okay, so suppose I have an input image of this 4 cross 4 matrix. I take the first array of first 2D array of 5, 34, 32, 54. Then I apply the max pooling to it. The maximum of those four values will be taken into the consideration for the next array, that the output array that will have this. Okay, and in similar way, we'll get the 4 cross 4 matrix. Average is done using taken, like we just take the average of the values, and in mean pooling we take the mean. So majorly in neural networks we take the max pooling. Okay, so now I am going to show a short demo. Till then, if you have any questions, if not, if something is not clear with CNNs. Okay, so I'll start. I don't think that we have any questions still for now. Okay, so simply, I have taken a Cypher 10 data set that is actually famous for like for the 10, say the to classifying as a 10 classes. We have 10 classes in this data set with 60,000 images, and yeah, it is very fun to play with this. And like it was obviously the first data set that I took. So I just wanted to take this and introduce how to code or how to simply write a neural network architecture. So we just start with importing of the TensorFlow. Then is simply importing matplotlib for plotting and TensorFlow.keras. Then I have taken I have used this data sets to import the Cypher 10 and applied this load data function to it, which is getting me the train images and the train labels and the test images and the labels. I've already run this notebook previously because I didn't want it to we face any technical issue right now. So I have printed the length of the images. Train images is 50,000 and the test images that we're testing is on 10,000. So first what I'll do is I'll start with normalizing the pixel values to 0 and 1. So we actually have the values of the array that we have of the image. The values are between 0 to 255, right? So it actually creates a, like, it will be a very difficult for the neural network to actually work with this large range of the range of the data. So we actually reduce it to between only 0 and 1. So we just divide all the pixel values or all the images values by 255. Okay, so these are just the numpy arrays. If you are confused of like what are the train images and test images, these are just numpy arrays which are like which will be inputted to the neural network. So what I have done, I have did some plotting of like how the like actually the images are looking for the class. Okay. So here I have written uh, the models. So what we are going to do is we are going to import we are going to use the models of sequential, and then what we are just going to add the layers. Okay, so we'll start with adding the convolutional 2D layer that we had talked about. The input size is like 32. neuron size, the number of the neurons that will be in this layer will be 32. We have a kernel size of 3 cross 3. We are using the activation function ReLU. We are using padding same, which actually adds extra, layer of to the image input. So we actually add extra, layer of array to the original array. Okay, and then we are having the input shape of the 32 cross 32 cross 3, which actually shows the height, the width, and the color channel, because the color images are colored. So we have three here, which is RGB, which is taken as RGB. Then we apply the max pooling to this, which is of the stride, which is of the size 2 cross 2. We have already seen here. Sorry, we have already seen here that how we took the 3 cross 3 kernel to the whole image. We applied that kernel to the whole image, and then we had some values, right? So what we are doing here also, we are just doing the same. We have some neurons, and then we have this 3 cross 3 kernel size, and then in the last we apply some activation. Then we have max pooling that we have talked about. How do we max pool? We take the maximum of the values from this array, and then we get the output array. Then one second, sorry. So then what we do is flatten. After adding some of the, say repeating some of these convolution and max pooling layers, we directly flatten. I have already explained flatten. It is simply a 2D array which is flattened into a 1D array. And then that is also passed again to a dense layer, which here consists of 5 and 2. You can change it accordingly, whatever works. And in the last, those dense layer is like is simply is outputting 10 values that are the 10 classes. Okay, I'm going to talk about this activation softmax. I've not the softmax is actually used when the values are not just say 0 or 1. We have a multi-class classification. Then we usually use softmax. Okay, we are also using some dropouts here. I've also added some dropouts. So actually, I was seeing some model overfitting. So I added some dropouts so that the model which is learning more, the training data set should not should not perform poorly on the unseen data. You can say the test data set. This is how I have plotted the model summary. And then I have simply used atom optimizer, the loss sparse categorical cross entropy, as we are dealing with multi-class classification, and then the metric accuracy. This is how we have used simply model.fit. We are inputting train images and train labels. I'm inputting some epochs, and we are adding some validation data also. Validation data is the data that is taken from the train images and test images, and it is on the same epoch. It is the train model is tested also. Okay, so this is how the training looked. With us, Abhi, it was quite a simple architecture. So the training looked fine to me, and the with the accuracy that we reached on the test data set was approximately 74.6%. So it was quite like if you guys starting on it, I think it is quite a good start for you. And then you can also try it on with some other data sets like cat versus dog, or you can say this data set, and then you can start contributing to some other taking some other data sets or other problems, and then you can start your way ahead. Okay, I just want to know if you have any questions till now. Okay, so one I've asked is what is the role of activation function? So activation function actually acts as a like on off button For example, we have 10 neurons in a layer, then how many neurons output should be feeded to the next layer is actually decided by activation function. So in the example that I have used, we have taken ReLU activation function. One second. We have taken ReLU activation function, so which actually just uh, take the maximum of the value. If it is less than if it is less than zero, then it will be zero, or it is the real value. Okay, so this is how it actually helps when we actually when we try to backpropagate for reducing the loss. It becomes quite hectic if we are using any other activation for sigmoid for sigmoid. So we actually use ReLU when for in between the tens layers. And softmax I have explained. When we are dealing with multi-class classification problems, then we use softmax. If you are just inputting just a one value or two value, just a one value, then it would be a signal. Any other questions, or I can stop? Okay, so let's move forward. If I try to summarize what we have done till now, is we have learned about what is machine learning. If you already know, that's good. But we had some traditional programming and the machine learning differentiator, how we differentiate between them. Then we move forward with two traditional machine learning algorithms of logistic regression and the linear regression. Then we knew about that we learned about why logistic regression is called logistic regression, and not logistic classification. Then we learned about artificial neural networks, why we have to learn, what was the need of deep learning for the introduction of the deep learning. We got to learn about how the architecture actually looks, deep learning architecture look, how simple artificial neuron in that deep learning architecture works. And then we got to know about convolutional neural networks, how to work with image data sets. And then we took a simple example of Cypher 10 data set and classified, which is classifying image in we have 10 classes with us. And in that we saw like how the layers are actually working, which layer work is what, convolution does what, activation function did what, and then what is the work of max pooling. So till now we have did the basics of ML and DL, and I think it will be a good path for you to start. Yeah, okay. So we have some questions. What should be the best train to test split ratio? Mostly it is taken to be 80 to 10. Whatever the data set size, it is mostly taken 80 to 10. You can take it around 90 to 10 also. It actually depends on the data set you are using, how to determine the number of layers in a model. Okay, good question. I will say it will be a trial and test method to how to actually learn what will be the number of layers in the model will be. I have mostly tried to start with, for say, 2 to 3 layers with different number of neurons. But which actually depends on the input array or input. Yeah, it actually depends on the input. So suppose we have an input of 256 cross 256, then mostly people start with either 512 or say 1024. So, and then they move on forward with 2 to 3 or 5 layers. And actually, it depends totally on the what activation function you're using, how much dropouts you are using, what are the number of neurons in the layer. So everything contributes to the learning of the machine learning. Are all neurons associated with weights and functions in neural network? So yes, at start, when we start with the simple architecture. We take a neural network, input neural network, and then we have some hidden neural networks, the neural, say neurons. Uh, the activation function actually decides which neuron is actually contributing to the next neuron or next layer. Okay, so suppose we had 10 neurons in a second layer, then it actually it depends on totally on the activation function, that either those 10 neurons will contribute to the next layers, or those 10 neurons, out of those 10 neurons, only 10 or only 2 or 3 neurons are actually going to contribute. Okay, I think I also forgot to tell about dropout. So dropout actually means how many neurons will have to be activated or will have to be passed next. Okay. So now let's move forward with the new buzz, the Gen AI thing that we all are facing, that we all are seeing on our LinkedIn or Instagram. You can see we see different videos that are generative. We see different memes that are generative, and that actually that actually highlights, or you can say that actually shows the future of AI, the future of what we are going to see in 5 to 10 years, or like we can just imagine, we cannot just imagine, because like 5 years back no one would have thought of that chat gpt thing can, like there can be a chat gpt thing, or there can be simply a chat bot that can help coders also, right? Though it's sometimes it's not that effective, but it helps, right? And people have started using keeping their content only up to the chat gpts, and now it is not just dependent to chat, it is also going forward with the image generation, and then now we have sora, like you can see the video generation, and now we are moving forward with like we are just keeping whatever we can think of from generative, we are just getting it through it. So I just wanted to discuss some 3 or 4 basic topics that we have with us. So that actually created this buzz. So this you can buzz. So it all started with attention is all you need uh, research paper. Which actually introduced us to the attention architecture, how attention helps in just focusing some part of the data that we want to work on, and which actually uh, is used in the transformers, right? Transformer architecture. So transform architecture, encoder, decoder, we have attention layers there also. So how transformers are used in large language models that we can see as chat gpt or the bard ai that we have with us, gemini, that everything is just transformer only. We are not only just seeing the use of transformer in text, we also see the use of transformer in images, which is as vision transformers. So we apply the transformer thing, transformer attention and all everything to the images also, and then we try to get the important, you can say the learn the important information from the image also, not just from the text. So we are using transformers, and it is helping us to get know more data, know more about it, and generate more data, right? Now next, which I wanted to discuss about is diffusion models, that everything we are seeing in generation, the image generation or the video generation is because of the diffusion models that we have. Diffusion models are actually uh, I am not going to go into the details because I it will it will be out of scope of this event. So diffusion model simply helps in the image generation thing, and the architecture is so cool. You can just start taking a look at the diffusion models, how that works. The simple basic idea is we just try to use diffusion from the, like you can say, the thermodynamics, and reverse the process of that, if you know. So these are the some things that are very new to new to the, like, say, AI people. Like when I started in ML, like nothing like this was like even like taught to me, or like talk to about talk to with me. So I think these are the terms that now college students can work on, and I think after having some basic understandings of how machine learning works, how deep learning works, having done on some projects, doing like experimenting with some models, I think one is like is ready to go forward with this. Okay. So next I'm going to talk about some resources that I use on my daily basis, and have actually helped. Okay, so the stable, like if you want to know about more about diffusion models, then you can go to the stable diffusion TensorFlow library. You can go to Hugging Face models. I'll just show you how to, because I think it has a very easy interface, but I still wanted to just give a short intro how to go through the models, how to check the models, what is the easiest. So I am just in this Hugging Face model section, and then you can see that we have some tags here that are multi-model tags or computer vision tags. Then you can sort these names according to the according to what task you are solving. Okay, so suppose you are working on an image segmentation problem, which actually like taking out the important part from the image, segment that part. So you can see the models which are currently trending. You can sort that out, which are currently trending, and you can take work on one of those models. For example, I take a look at this Facebook DETR ResNet 50. So you can simply use this model. Here is a short introduction, like how, and here is also like some code like to start. You can also fine tune these models according to your tasks, right? So, for example, if you have your own data set ready, and if you want to just take a pre-trained model from here and want to just retrain the model according to your tasks, then you can use the models from here also. Okay, so yeah. So my next go-to thing is obviously open source GitHub, which actually is like say it is never ending. The people are always solving some problems, and having like the models are there either in the Google Drive, or sometimes it's difficult to find them, but it is helpful to just take like go through GitHub, go to GitHub and check for the problem you're solving, and see if there is already some work done there or not before starting with yours. That could be a great start. Okay. Next we have archive or papers with code. That obviously is a, like very important term in the machine learning and data science field. And in last I have added course like that is the deeplearning.io. You can take up those courses also. Those are very good to start if you have a like if you want to just get started. Then you can go to these resources that I have listed above, and then start working on it. I also want to discuss about PyTorch. I think many less there is like when we are in college, there is very, I don't think there is many like work done around PyTorch when we want to be a ML engineer or a data scientist or a deep learning engineer or a computer vision engineer, whatever the term is. But I think PyTorch have really helped me. It is more Pythonic. Like the models written are more good, so you can start with that also. And obviously the TensorFlow, I have show you TensorFlow is go to. It's easy to use, and you can start with that also. Just try to be very lenient, and to just adapt whatever the requirement is. So now we have Q&A. I've already taken some questions in between also. So if there are any questions, we can take them now. I think I'd had a one question that I left. What role do optimization algorithms play in training neural networks, and how are they mathematically formulated? So mathematically, I'm not going to tell you, but yeah, so it is simply you can connect with me, Man Kumar, and we can talk on this, right? Uh, Literally, like I think it will be a good talk to discuss maths behind the automatizations like Adam Optimizer or anything like that you have worked on or that you want to work. So simply we just when we want to adjust the hyperparameters, then we use optimization algorithms that actually aids the process, the aids the whole process that we have with this. So if we have any questions, I'm waiting. How much do we need to know to get into IT industry with ML as a fresh? Okay, good question. This actually is a very overwhelming. It becomes very overwhelming when we are a fresher and we want to start in ML. Like even right now, I feel that I have to stay updated with the current trends and I have to keep learning. So if you are just a fresher, I can say if you're just a pass out, the actually the recruiter tries to see if you have done any internship or not, previous internships. Or a plus, if you have done some internships, uh, either 2 months, 6 months, that doesn't matter. If you have done some contributions to open source, I think that also contributes very much. So if you want to be into ML, then I think you have to just like show your work. If you can show your work, then there will be like no issues with the hiring manager or anything, that anyone that you have to work with, he or she will be happy to hire you. So just have to showcase your work either with some internship or with some research paper or working open source, or you can say just try to be active in communities also. So if you start learning, start showcasing your work, I think you'll be good to go. I also started as same. I had to internships experience, and I had done some projects, and that actually helped me clearing the interviews. And yeah, so I think that's a basic path you can follow. Anything else? If not, then I think here is my QR. And thank you for the session. If you have any questions, you can directly connect with me either on Instagram or either on LinkedIn, Twitter, or you can also see some projects on GitHub. And yeah, sure. I like if this session was helpful, I think my work is all done, and you can just directly connect with me, and we can have some chat if anybody wants to dive more into these.
Okay, so that was an amazing session, Kritika. Thank you for the insightful presentation. Uh, yeah. So, like, we got the questions here already. Anybody wants to ask a question, please just drop in the chat box. Okay, I guess we got the questions and the session got in. So, guys, we okay then. Till then, thank you so much, Kritika. It was a good session. See you next time.
Okay, so are we done? Dev?
Yeah. Thank you so much for the session. And
Thank you everyone for joining. Thank you so much, Kritika, for joining us and enlightening us with the awesome topic. And I hope we'll be
Thank
like
you.
able to collaborate with you in the future as well, especially in our offline events.
Yeah.
Thank you everyone for joining, and we'll be here for day 5 on Wednesday. So stay tuned to our channels and socials, and also do give Kritika a follow and connect. On LinkedIn. I have dropped the handle in the chat box, and also it will be available in the description of the video. And yeah, this video will also be available on YouTube, so you can share it with your peers and friends. So thank you, everyone.
Thank you.
okay, thank you, everyone.